Okay, so we are working on Advent of Code, day 6. No, day 8, sorry. Today I brought a much needed beverage, since it's the first stream that I've done in the evening. All right. Oh, hey, Avery. How's it going? Okay. So, by the way, thank you, Avery, for the suggestion of streaming these solutions. It's been pretty fun so far, but I am pretty confident that I'm not going to make it to the end. Streaming every day is really hard. Okay, day 8, 7-segment search. You barely reach the safety of the cave when the whale smashes into the cave mouth, collapsing it. Sensors indicate another exit to this cave at a much greater depth, so you have no choice but to press on. As your submarine slowly makes its way through the cave system, you notice that the 4-digit 7-segment displays in your submarine are malfunctioning. They must have been damaged during the escape. You'll be in a lot of trouble without them, so you better figure out what's wrong. Each digit of a 7-segment display is rendered by turning on or off any of 7 segments named A through G. So this is A, B, C, D, E, F, G. Okay? So this is how we'd render a 0. This is how we'd render a 1. So to render a 1, only segments C and F would be turned on. The rest would be off. To render a 7, only segments A and C, A, C, and F would be turned on. The problem is that the signals which control the segments have been mixed up on each display. The submarine is still trying to display numbers by producing output on signal wires A through G, but those wires are connected to segments randomly. Oh, wow. Worse, the wire segment connections are mixed up separately for each 4-digit display. So we are viewing a 4-digit display. All of the digits within a display use the same connections, though. Oh, there's multiple 4-digit displays. Okay. So you might know that only signal wires B and G are turned on, but that doesn't mean segments B and G are turned on. Okay, so the signal wires and the segments don't necessarily map one-to-one, but that doesn't mean segments B and are the only digit that uses 2 segments is a 1, so it must mean segments C and F are meant to be on. Yeah, this one sounds tricky. With just that information, you still can't tell which wire, B or G, goes to which segment. For that, you'll need to collect more information. For each display, watch the changing signals for a while. Make a note of all 10 unique signal patterns you see. Then write down a single 4-digit output value, your puzzle input. Using the signal patterns, you should be able to work out which pattern corresponds to which digit. Okay, for example, here's what you might see in a single entry in your notes. Okay, so this one has to be a 1. So that means that this is either C or F, and this is either C or F. Okay. And then I don't think I quite understand what's happening at the very end. Write down a single 4-digit output value. That's this one. So I have to read what this number would be, this 4-digit number. The entrance wrapped here for 2 lines. Each entry consists of 10 unique signal patterns, a pipe delimiter, and finally the 4-digit output value. Within an entry, the same wire segment connections are used, but you don't know what the connections actually are. The unique signal patterns correspond to 10 different ways the submarine tries to render a digit using the current wire segment connections. Because 7 is the only digit that uses 3 segments, DAB, in the above example, that means to render a 7, signal lines DA and B are on. Because 4 is the only digit that uses 4 segments, EAFB means to render a 4, signal lines EAFB are on. Okay. Using this information, you should be able to work out which combination of signal wires corresponds to each of the 10 digits. Then you can decode the 4-digit output value. Unfortunately, the code example above, all of the digits in the output value use 5 segments and are more difficult to deduce. For now, focus on the easy digits. Consider this larger example. Oh, hey, Luke. How are you? Quite late for you, I imagine. BE, CD, CFBE, GAD. Okay. Because the digits 1, 4, 7, and 8 each use a unique summer. Okay, yeah, that's how we're going to figure this out. You should be able to tell which combinations of signals correspond to those digits. Counting only digits in the output values. Counting only digits in the output values, the part after the pipe on each line. Consider that there are 26 instances of digits that use a unique number of segments. This is a tough puzzle to even understand. Yeah, 1 a.m. for you. I imagine that you'll... I'll put you to sleep rather quickly. In the output values, how many times do digits 1, 4, 7, or 8 appear? Okay, so we know, regardless of what the connections are, a 1 takes 2 segments to display. So any of the 2-digit ones are going to be a 1. A 4 uses 1, 2, 3, 4 segments. A 7 uses 3 segments. And an 8 uses all of the segments. Okay. So we can at least count only digits in the output values, the part after each. What does that even mean? Counting only digits in the output values. In the output values, how many? Okay, the question makes way more sense. In the example above, there are 26 instances of digits that use a unique number of segments. Okay, so let's grab this test first, and we will end up parsing. We're only counting the digits past the pipe. Okay. Hey, Dennis, how are you? Okay, so let's go grab a day 8 folder. Day8.swift. And then in here we will do a walk and several coffees of some elusive. I'm a little scared because I don't have a lot of time. I have about an hour. I hope that I can finish it. Okay, let's do static func run. We'll grab our input, which will be read file day8.test. And then I will just print it out for now. And then let's go over to main.swift. Okay, and let's add the input file day8.test. Okay. Okay. Let's build. Let's run. And we have our input. Okay, so we need to parse. We can split on the pipe and then split on spaces to get our different digits. So we can take that input, split separator pipe, and then for each part we'll have essentially two parts here. So assert that parts dot count are 2, and then we can be parts 1 dot split, or 0 rather, on the separator space, and then compact map those to strings. Don't need compact map, just split. So this is our sequence patterns. Let's call it patterns. And then we have our output digits. Digits is parts 1 dot split separator. Okay, let's first print out patterns. This is not going to work. I need to do lines. Let me grab a quick struct to represent our display. We'll have patterns be an array of strings, and we'll have output digits be an array of strings. And then I think I will grab an initializer that takes in the input string for each line, like this. And then this will be input.lines.map to display.init. All right, let's see if we get our displays. Cannot assign the value of string subsequence to. Okay, so it's funny because I just watched a point-free episode where it talked about how you can save quite a bit of memory by using substrings and array slices and things like that to not have lots of copies. But for now, I'm going to not care until it's a problem. Okay. Okay, we got an assertion failure, which would have to be this one. Let's see. Let's print out single line input, and then let me run over to here and run it. So I have a problem still with my Vim setup where my output won't show me standard out and standard error at the same time. Input.lines.map. The first one, let me take a look at my input. Is that a new line? I haven't hit a puzzle yet where parsing is a bottleneck. Yeah, I just found out about that library today, the Swift parsing library. I need to take a look at that a little bit more. I think this is on multiple lines. Is the puzzle input like that also? I don't think so. No, it's all in one line. So let me just fix up this input to be exactly what we expect. Okay, so, here's a bit of Vim fun. I can do let's see, at Q, no, where am I? At Q. Now I forget how to do it. What is my keyword? Oh, there it is. Okay. QQ, that's what it is. So I'm recording a macro. So I will hit Shift J to collapse the next line to this line, and then I will just move down one more, and now I will hit Q again to stop recording. And now we can say at Q, at Q, at Q to like just keep going through the file like that. There's probably a faster way to do that, but I honestly don't use that too much, but occasionally it's very helpful. Okay, so now let's run it. Also, assertions are super handy. Okay, so we've got everything that we expect here. So now this should be super easy where I say display.filter out displays whose number is a 1. Is 1 display string. I'll just call it, what do I want to call this? Sequence or something? Segments is an array of string. Okay, so I actually have these, and I'm going to be grabbing character counts for each one. So each one is 1 digit. So this is segments is a string array, and this is going to return the bool. So this one will return segments.characters.count or segments.count. That would be equals 2, because we know that it is definitely a 1 if there's only 2. We can also know that if there's a 4, if it is a 4 here, like this one, 1, 2, 3, 4 segments. Segments.count is 4. We've got a func is 7. Segments is a string. And this will give us segments.count is equal to 1, 2, 3. And then what was the last one? 8 is if they're all on. Okay. So this will be displays.filter. We want to grab if these are is 1 or is 4 or is 7 or is 8. And this would be mapping to their output digits. Okay, output digits is an array and displays is an array. So this needs to flat map to get all of them in a single array, and then I can filter all of those and then do count. Okay, print count is 7. Misspelled. Okay. Can't find is 8D. Okay. Instance members, of course. So these all need to be static. Okay. Let's run it. 26. Okay, so we get the correct answer here. We can switch over to our test input here, copy that, and then go to day 8 test. And here we're going to add day 8.input, paste that all in. Okay, that looks good. Nope. Want to go to day 8.test. I mean day 8.swift. Okay. Of course, I have to change my input reading to use the live one. So 488 is the answer. Okay, part 2. Through a little deduction, you should now be able to determine the remaining digits. Consider again the first example above. After some careful analysis, the mapping between signal wires and segments only makes sense in the following configuration. So the unique signal patterns would correspond to the following digits. Then the 4 digits of the output value can be decoded. Okay. The output value for this entry is 5353. Following the same process for each entry in the second larger example above, the output value of each entry can be determined. Okay, so we actually have 2 test cases. I wonder if I should just start with this one, get this one working. So we will comment that out for a second and just have this guy. as our input. Okay. So at some point, how do I want to do this? We can identify the ones that should be in there. And then I wonder if we could create a mapping of like, here is a wire and one of its actual possible labels. So something like, let's make this a class. Because I want to be able to mutate this repeatedly. So this one would be something like possible matches, something like that. You know what? I feel like this is kind of like solving a Sudoku puzzle. Like you can't just solve it in one row or one column. You have to kind of work backwards and make hypotheses about like, what if I make this one a 5? What does that do to the rest of the puzzle? That's what it kind of feels like. Okay, so possible matches would go from a single character to an array of characters. Okay, so if I had that, and we sort of want to solve and eventually have our possible matches returned with the right numbers. This would eventually solve and give us an int. For now, we'll return 0 because I don't know what we're doing yet. But so here we're going to need these functions down here instead. Let me move those all down here. And I can get rid of the static on each one. Okay. Okay, so this one would say, it's going to say let output equals oh wait, this is display for a single line, and then we'll have an array of displays. Let's call that a display solver that gets initialized with a bunch of displays. Let's do that. And then the possible matches go up here. Each display is parsed that way. Then I have the solve, and all these function as part of the solver. This can go back to just being a simple struct. And then we can have a static func parse. Input string returns self. Okay. Get rid of output. So we need solver equals display solver.parse. Input. Then this guy goes into here. Okay. Self has no member in it. Okay. Okay, so we no longer need to print those out. Solver, display solver.parse input. This will be solver.output. Or was it solve? Yeah, solve. Print output. Okay. Can't find output. Scope. Constructing an object with self with a metatype must use a required initializer. Okay, let's just do display solver. Okay. Okay, so at the start, we can fill all possible matches. A, B, C, D, E, F, G, right? 1, 2, that's 1, 2, 3, 4, 5, 6, 7. We can do dot for each, do character. How do I want to do this? I keep wanting to write Ruby. That's hilarious. Will it let me loop over a string like this? I know it's unsafe, but it doesn't matter in this case. Okay. Okay, so in this case, possible matches for this character equals all of these same possible matches. So let's grab all segments to be that. And I want to all segments dot map $0 to get an array of characters. So at this point now we have everything, every single wire could potentially point to any of the wires. Okay, so at some point now I need to essentially do a while loop until this is solved. But we need to fill in the hints that we know. So we can say that for each display, we have the sequence. Oh, wait, I need to solve this for an individual display, right? And then I get a 4-digit number for each line. Is that correct? Do we add them all together? Yeah, you add them all up. Okay. So the display solver takes in a single display. Yeah, let's do that. Takes in a single display, does the solution, and then yeah, so this parse needs to belong somewhere else. This will basically be get all the displays, and then displays.map to display solver.init. So that gives me a bunch of display solvers, and for each one, we want to call solve .map solver.solve. That gives me a bunch of outputs. And let's just print them out for now. Eventually we'll add them up. Okay. Okay, so now I'm looking at for each segment in a given input string. So we're looking at this one, let's say. This has 1, 2, 3, 4, 5, 6, 7. 7 entries. So we don't quite know what that one is. And when I get to one that has 1, like that one, let's just search for that one. So if I say for pattern in display.patterns, if it's a 1, then I know that the two characters, so possible matches for each of the characters in this pattern, pattern dot for each char in, the possible matches for that character are pattern dot map $0. Okay, so if we're at the very end, all possible matches for this pattern. For each remaining character in this pattern. Let's see. It's interesting, though. I will have to revisit the case of what if I thought that A had only one value before I got to this point. Then I would need to reconcile that and say, I guess take the union of the two and say, oh, this is the only one. Not the union, the intersection. I don't know. At the moment, I'm just going to print out the possible matches for our single point of input and then return 0. So we've got one line of input. We'll create the display, the solver, try to solve it, print it. Okay, so B has possible matches of A and B. Oh, wait, no, it's not A and B in this case. It's whatever the possible matches were in the original one. So in a 1, that would be C and F. I need to copy this diagram, at least for the 8. It's possible that I don't necessarily care what their actual numbers, what their actual segments are, if I can figure out what the patterns are. But that's going to help me in the final pattern, I believe. Should see the chaotic notes. I scribbled. We'll try to solve this one. Did you did it on stream? Okay, cool. I will have to check it out after I'm done. Okay, so for each, if it's a pattern, if it is 1, then both of the patterns here are going to be an array of C and F. And I may have to intersect any like additions here. So I could perhaps start off with all of them being, well, yeah, I'm going to have to do that. I'm going to have to intersect with what is already there. And I know it's already there because I just filled them in. So the possible matches for this character, it's interesting because I don't care if that character already has one element, then I don't need to do anything. Next, continue. I can't do that. So fork char in pattern. It's one thing I don't like about the for each is you can't like say continue in a for each like that. Sorry, in a dot for each. You can with a normal for in loop. Okay, continue. We're done with this character. Otherwise, we will take the existing ones and intersect them with this one. So I wonder if this probably should be a set instead of an array, perhaps. Set of character. This would have to be a set of characters like that. We have no closure param there. We know that that will have a value, so I guess I could force unwrap it there. Possible matches here. Let existing matches or previous matches. Possible matches for that character. And then we will say previous matches dot intersect with this set. Yeah. I think that would work. Set character has no... Okay, hang on. Let's grab this up front. Let's just call it matches. Okay, intersect. Union intersection gives me, it returns a new set, yeah. Okay, so at the very end we should see possible matches for C, is that one, G? Which one? So A and B are the ones we were looking for. Yeah, so A becomes the set of C and F. Okay. Cool. So now if we know that if it was 1, we can just continue here because it's not going to be any of the others. So then I could say if is 4 pattern, and we're essentially going to do the same kind of thing. So this will probably be refactored at some point. So we'll get all the possible matches. We can skip ones where we are already 1. Possible matches. Okay, so what the values would be in a 4? It would be B, D, C, and F. B, D, C, and F. So this is B, D, C, and F. Okay, if is 7, and this is kind of like my rule of 3. I've done this 3 times now, or I'm about to do it 3 times now, so all of this can be extracted and just, this would be sort of like an update. Let's see. Private func update matches for the pattern, for this pattern. And this would be possibles, would be an array of character. Something like that. So I'll take all of this and say that we can now return matches dot intersection with the possibles from this one. Yeah. Okay. Update matches for pattern, possibles, C, and F. And this was B, D, C, and F. And if it's 7, we'll grab A for the top, C and F for the right-hand side. And then the last one, continue. So it'd be if is 8, Date matches for pattern. This would be all of the segments. Does 8 help us at all? Doesn't. I don't think it helps us at all because there are no, we would not be intersecting anything, so who cares? Okay, so at the end of this, let me print out this a little bit better for char in possible matches dot keys dot sorted. We will print out the character and then print out that character's possible matches. Like this. Possible matches for that character. Force unwrap. And then I actually also want to say joined separator empty array. Okay, unexpected comma separator. Let's see, I have that messed up. Okay. Terminated string literal. There we go. That seems fine, I think. Referencing instance method joined separator on requires that character conform to sequence. Do I need to map this to string.init, then join it? I suppose. Okay. Okay, so A has a possibility of FC. B has a possibility of CF. C has A, B, C, D, E, F, G. D has ACF. Okay, so at this point we know that D... No, what do we know about this? Did this help us at all? It certainly whittled down many of the numbers. Something a little easier to read. Okay, so at this point now we would have to know in the output, can we solve any of the digits in the output? Okay. So if we look at C, so none of them have a 1, that's the problem. But there's probably some invalid positions, let's say, where like if this means that if A is on the right, top right, let's say, let's grab my screen brush thing. Yeah. Let's see, option, tab. Yeah, how do I clear? Clear screen, command \. Okay. So if this is our 7-segment display, and we're saying that A is right here, A, then that has implications for the rest of it. So if we later said that that was a 5, well, a 5 can't contain an A because that would make it invalid. So let's see. I suppose I could bring out, like, here are the possible digits that something could be, which would be like kind of combine all possible permutations of the possible characters in the pattern. So this would be like looking at just the first one. Let's say if we just look at the first output, this one, CDFEB. So if we look at the permutations for that one, I almost want to print out what this looks like. If it helps, I made no attempt to try and map to wired segments. So here's the thing. I don't know if that helps or not. I don't know if I'm just headed down a path that is like a painful solution, or it would take me more time to get in the headspace to utilize that tip. No attempt to try and map to wired segments. Okay. Because it does sort of seem like map wires to segments. I see what you mean, yeah. The ways that I sort of viewed this is kind of like auto layout. The auto layout, I forget what that constraint solving algorithm is. It's like something with a C. Cassowary, maybe? I think. Let me search that. Yeah, solves systems of linear equalities and inequalities. I don't really know the details of this, but it just sort of got me thinking about this type of solution where you essentially have to run simulations and whittle down the possibilities and then eventually choose one. In that case, there are many solutions to those problems, so it's not quite the same. But that's kind of what I was thinking, is I would just say, okay, let's just do one pass and go for the known things. And then we might do another pass and say that given what we know now, I can now eliminate more possibilities. I also did not try to figure out the identity of the segments, but my method can identify them if you wanted to. Okay. So if you don't identify which segment is which, my hint is to stare at LEDs for a while first. Yeah. I assume you mean 7-segment display. Yeah. That was actually a serious recommendation and not a joke. Okay. Okay. let's. Okay. Now, don't get confused by the letter combination here. Let me. Because these letters are different. Look how some numbers differ from others in their patterns. Yeah, I can see like 8 and 9 are essentially the same with this slot removed, but so is 6, right? And a 5 is an 8 with 2 specific slots removed, but so is 3 and 2. Look at 7 and 1. 7 and 1 are identical with a single number added. But we already know which ones are the 7s. Right? So if we know which one is the 7... Oh, okay. If we know which one is the 7 and which one is the 1, we know the odd man out is the top segment. Yeah. 7 minus 1 gives us the top segment, or A. Imagine segments as sets, and that's when I went for a walk. Yeah, okay. Yeah, so I'm actually doing the union here with sets. Even if you just consider these, I think you can consider them as sets as well, because you have the notion that one segment entirely contains the one. So like 8 is a superset of all of the numbers, and 6 would be a superset of 5, but not 2. This can be solved without knowing which segment is top. Yeah, I am getting the I'm getting the idea that throughout this Advent of Code series, my solutions, like, I'm not always happy with them, and I'm sure there is a better way, but I think that you just got to plug away at a solution, and not like spend too much trying to come up with the perfect solution, right? Because the goal is to get through it and not break your computer. Another pattern to look at is comparing 6, 9, and 1. So we're looking at 6, 9, and 1. So that's 6 and 9 are essentially rotated. Or if you take 6 and 9 and 1, if we take 6 and 1, 6 minus 1 will give us this segment. Yeah. 6 and 9 have the same number of segments, but only 9 shares all of 1's segments. Yeah. You don't break your computer until day 14. That's not true. I broke my computer on the lanternfish. And eventually realized that modeling each individual fish is not a scalable solution. Okay, so if we know which one is 7 and which one is 1, okay, do I need to save these patterns so I can know? This is kind of annoying, but because there's no guarantee that there's even going to be a 7. I don't really like doing this, but for now, until I have a better idea, I'm just going to start. Update matches, and then we're going to save the 1 pattern equals pattern. And then here, this will be the 7 pattern. In the groups of 10, they give you every digit. Oh, okay. That's useful. I don't know if they told me that, but certainly useful. So the 7 pattern is, so it's interesting. After I've gone through every single one of the patterns, looking for the known ones, I can then just look for them. But that's fine. For now, I think this will probably change, but let me just get started. So 7 minus 1 gives me the top segment, or A. So in this case, set of, if let 1 equals 1 pattern, let 7 equals 7 pattern, then here we'll take the set of 1 dot map $0, and can I just subtract it? Set of, no, this is 7. 1 dot map $0. Why doesn't it like that indentation? Is this just not valid? Probably that for loop. Can't, okay, so subtracting. Okay. So at this point, we assume this A dot count is 1, right? And then we can say that in the possible matches for whatever A contains, I can't index like that because it's a set, but I could just say remove first, or just first. Isn't there a way to do this? This is the downside of doing it with Vim, is I'm not getting code completion at the moment. So we could say A dot remove first. No, but that's going to mutate A, and it's not going to like that. Okay. I feel like there's just a first. It's not first object. Oh, I'm overcomplicating it. Okay. So possible matches A dot first equals A. And that's a single one. Okay, so at this point now, we can do 6 and 9. 6, 9, 1, all 6 and 9 have how many? That's 1, 2, 3, 4, 5, 6. Okay, so we're going to find we need to find the patterns that have we're already looping, actually. Why am I looping inside of here? I mean, I kind of wanted to loop, right? I wanted to keep looping, but then I may need to start over and loop again because now I might have more information. So here we'll say if pattern.count is equal to if pattern.count is equal to 6, and then we will, but here's the other thing is I need to know that I've already captured these first ones. So if I say let 1 equals 1 pattern, then I could have seen a 6 ahead of a 6 count one first. So it definitely means I would have to iterate over this again. Okay, I think I'm gonna just, I either could sort the patterns by their length, and that would solve this thing. Sorted A, B, where in a dot count, I didn't use a loop, I'll only use a loop for each line of input. Okay, let me stare at the input for a second. So you're just finding the ones that have 6 in there. Yeah, that's probably better. Because the loop isn't, I'm like fighting the loop already. Yeah, okay. We can just say that one pattern is, if you solve them in a particular order, you can do it in a single pass. Okay. But I still have to sort of find them in this set. So I could say display.patterns dot first where $0.count is equal to 2. Right? And then I don't even need this. Yeah, I think that's probably better. Or I could say first where is 1 if I want to keep the does that work? Okay, we're not going to be doing that, but let me just get it to solution here first. Okay, so the 1 pattern is that. The 7 pattern is display.patterns.first where is 7. The 4 pattern is display.patterns first where is 4. I'm not sure I like these, honestly, because the name doesn't really, we already saying it's 1. We can just say the count here. 174, those are the only ones that I think are useful. Actually, no, 8 pattern is useful. I still need to know where is 8. Or do I? No, actually, I don't think I need to know that. Okay, so then I could say 9 or 6s. Patterns dot where filter count is 6. oh, we also need to do 7 minus 1 gives me the top segment, or A. Okay, so this would be update matches for one pattern if it exists. Don't actually need to know the top segment. I just mentioned that in case you really want to proceed with it. I don't know. I feel like I'm close, but like this gives me the top segment, right? Or A. I guess what you're saying is that if I just keep staring at this, I can keep reducing down until I get to with all possible matches. Yeah, okay. I believe you. I'm going to continue without the possible matches thing and just see if I can get this part done. So you can evaluate all the patterns without needing. Okay. So this one becomes 9 or 6s, right? These are all lets. Then 9 is out of 9 or 6s. Actually, no, I could just say 9. Find the one that is a 6 and the set of $0. I need to map that. $0.map $0. Got to be a better way to read this. Maybe I map this into a set already. It's actually, since I keep wanting to turn them into a set, I think that the set needs to be here. This needs to be an array of sets of character, I think. Same thing here. I think that actually will simplify the rest of this. Yeah, create a set of that to map to $0. Okay. Cannot convert value of type. Okay, so now I don't think I actually want any of these helper functions. They don't really help me any. These I don't think are very useful, so I'm going to avoid doing those. So this will be where $0.count is 2. $0.count is 3. Count is 1, 2, 3, 4. Is that right? 1, 2, 3, 4. Okay. So now if we are filtering the ones that have 6 and one that intersects between 1. So we actually are asserting that we have these, because if we don't have these, then we can't figure out the rest of the input. Okay, so then here we'll say where the $0 dot is strict superset every member of A is a strict superset of B if every member of B is in A. Yeah, so if 9 is a strict superset of B. Yeah, okay. Is strict superset of one pattern. Let's just call it 1. Okay. Okay, get rid of all these. Yeah, 9 gives you the 6. That'll be first where. There's another digit with 6 segments, okay? There sure is. So in order to get that one, I need to see if it has the same as 4. Or not. Yeah. So this would be 0. It displayed up patterns where blah, blah, blah. That is a strict superset of 4. No, 6 is a strict superset of 4. 6, and that would be 0. Okay, so this would be is strict superset of 4. 6 is the one that doesn't have both segments 1. Right. Yeah, because that's what I'm saying. Find me one that has 6 elements and has all of the same ones as 1 does. Or sorry, backwards. That 1 is contained within this number. And then 6 is 6 isn't a superset of 4. What am I doing? I'm trying to choose between these two, and the one that has let's see. If I subtract 1, so actually 9 and 0 are messed up. Yeah. 6 is the one where it's not a strict superset of 1. Okay. Because 0 and 9 are. And now I need to see if 9 and 4 intersect. And then there should only be 1 left over. So where it's 0 is not 9, and $0 is not equal to 4. No, 6. God, this is so confusing. All right. Let me fix up these remaining errors. Okay. Didn't identify 9 until after 5. It's possible I have a bug. I don't know. Can't assign a value of set of string. I don't want a set of string. 5 is easy to identify when you have 6. Okay. I have parts.0.split on separator gives me an array of substrings. I don't actually want to map that to $0. Actually, I thought that that would actually give me what I want. Mapping a string gives me characters. Why isn't this working? Oh yeah, okay. Now I know what I need to do. We have an array. This one is mapped to a set. Segment isn't the right word. This is pattern. Set did a net for string pattern. Actually, we could probably just say pattern.map $0. Probably give me characters. Yeah. These are literally the same. Is array string? Yeah, that does seem way better. Yeah, that's way better. I kind of miss the characters view, but I know why they took it away. Has lots of weird implications for Unicode stuff. Okay. The fact that these are identical is really annoying, but whatever. I'm going to resist the temptation for the moment. I don't need this anymore. I'm now building. So at this point now, we should be able to identify 1, 7, 4, 6, 9, and 0. 5 has 5. And if I look at 1, 2, 3, 4, 5, so that shares one with 2, 3, and 5. Do I know which segment this one is? In another one. 0. Yeah, 5 and 6 are the same except for this one. 6, it's a strict superset. It's the only strict superset of 6. 5 is display.patterns.first, where $0.count is equal to 5. And $0 is a strict superset of 6. Subset. Is subset of, is strict subset. I don't think I want a strict subset. And contains at least one element that is not a member of A. I guess it doesn't matter in this case, but yeah. Okay. Okay, so we need 2 and 3, right? 8 is easy. Display.patterns dot first where $0.count is 8. Okay, 2 and 3. They both have 5. They're both subsets of 8, but 3 is the only subset of 9. Is a strict subset of 9. You can find 3 by removing segments from 1 and counting the remaining segments. You can find 3 by removing the segments from 1 and then counting. Yeah, that's true. Is strict subset of 9. And then finally 2 is the last one that we have. So this would count as 5 and it's not 3. It's not equal to 3 and not equal to 5. Okay. Let's see if it crashes. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that was a great tip. Staring at the LEDs got me thinking about pattern recognition rather than iterative solving. Okay, it crashed on line 47. So we have a bug with number 8. There were no count as 7. Okay. All right, it found 1 for every single one. So at this point now that I have them, we can, I suppose, sort them and then compare with the output digits. No, those are already a set, which is amazing for us. So now we can say output digits are those 4-digit pattern in display.output digits. We will see which one of these matches. How do I want to do that? Digit pattern. We can perhaps grab something like this. So it would be a set to integer 4, 5, 6, 7. Okay, and this is our lookup, which, let's go here, potential bug in line 48. 5 is also a subset of 9. Thank you. So that would be and not equals 5. One thing I can say, $0 not equal 5. I think that sort of find a single value and fail if it doesn't exist, because right now I'm at force unwrapping. if I get 0 elements. So it'll crash if I get 0, but if I got 2, that's also a mistake. And this doesn't help me avoid that. Okay, so now in my digit pattern, I can grab the value. Let's print out the digit is digit pattern. Value is value. We'll grab the lookup for this digit pattern. We'll force unwrap it because we should have already grabbed it, and we'll print those out. Okay, 5353. Why doesn't it look up as 0 or 9? Because it's late. I guess this would crash later. Okay. So B, C, D, F, E. B, C, D, F, E. 5353. Is that what they said it was going to be here? 5353. Yeah. So then I add this. Okay, so each one needs to be multiplied by. So let's do enumerated. And we could actually do a sum here. Display.output digits enumerated, reduce into 0, and then give me back the sum and the pair. And then here I'm going to take the value. This will be the digit. The value is going to be, let's see, if there are display.output digits.count. Output digits.count minus pair.offset, I think it is. That gives me how many multiples of 10 this is. Is that right? Can't find POW in scope. Because it's in Foundation? Seems strange. I would have thought that would be in the standard library. Okay, so now this is going to be pair.element. Will give me the pattern. Then I could say POW, so that's going to be like 10 to the. This is the worst documentation ever. Raised to this power, yeah. So this would be 0. If I need to do. So if the offset is, let's say this is a 4-digit number. So there's 4 and my index is 0. So then I do 10 to the 4th power, which is wrong. I need to subtract 1 from this. And then multiply that by a digit. And then return sum plus value. Maybe... Oh, come on. This is only on decimal. Man, it's, you know, it's an old Swift. Do I need to do this? Initializer init requires a decimal conform to binary integer. I think it's just assuming that's a decimal number. Okay. Shouldn't the subtraction also be 1.0? Int.init string exists. Just saying. So you're like saying take the digit and then say plus 00 or whatever. Yeah, that could work. Should the subtraction also be 1.0? Yes, it should be. Okay. I didn't return anything here, so let sum be that, return sum, build, run. Why am I getting an array? What am I printing out here? I'm getting an array because we get all of the outputs, and I need to sum all of them. This is summing, yeah, this is summing the single, like, display value. Let's call that display value. And then later I need to take that, all those outputs, and we'll print them out. And then I'll say, let sum is outputs dot reduce 0 plus, and print the sum is sum. Match each digit to a string, join them, pass the whole string to int on init. Yeah, that would have been easier than what I'm doing. Though mine arguably might be faster. I don't really know. It doesn't really matter. Okay, so if we take, just to run this again, I should get the same answer. I do. Okay, and if I take the 10 test input. Sum is 61,229. Let's double check that that matches. It does. Switch over to input, build, and run. Oof. Okay. That was a hard one. I was certainly going off on a different path. I think the pattern matching was easier.